Hey everyone, welcome back to the series where we are building a whiteboard Android app from scratch. In the last video, we designed the basic app screen, and today we are diving deeper into how we can actually draw on our canvas. We will explore the Compose canvas coordinate system and understand what paths are and learn how to capture user inputs for drawing. So let's get started. First, let's talk about the Compose canvas coordinate system. If you remember from math class, we usually deal with a coordinate system where the origin 0, 0 is at the center and the x and y coordinates extend both positively and negatively. However, in Compose canvas, the coordinate system is a bit different. Here in Compose Canvas, the origin 0, 0 is at the top left corner of the screen. The y-axis increases as you move downward. The x-axis increases as you move to the right. This is different from the typical Cartesian coordinate system where the y-axis increases as you move upwards. This is something we keep in mind as it impacts how we place and draw elements on the canvas. Understanding this system is crucial. When you start drawing shapes, paths, or other elements on the canvas, you need to know exactly where you are placing them. A solid understanding of the coordinate system will help you accurately map out your drawings on the screen. Now let's talk about paths. In Compose Canvas, a path is essentially a series of connected points that can be a straight line or curves. A path allows us to define complex shapes or drawings with precision. Think of a path as a trail that you leave behind when you move a pen across a paper. Every movement you make adds to the path. Alright, now that we understand what paths are, let's see how we can actually draw them on the canvas. So here let's go to our whiteboard screen, and in the last, let's create one composable function with the name drawing canvas. So to draw something on the screen, we have the canvas. Here we can get this canvas composable function. This needs the modifier, so let's use the modifier from the parameter. And first thing, let's use a background. And for the background color, let's take some color from our theme package and this color file. For now, let's just copy this color and use it here. And in the left side, you get a box with that color. So let's click on this. And here we can select a color. So let's select something light. This one. And to preview this, let's create a preview function. And let's open our preview window. So here we are not seeing any preview because there should be some size so this canvas can get the measurements. So let's use our modifier and give the fill max size modifier. Now here we can see the preview, and let's click on this fit zoom to fit, and here we have a canvas, and let's select some lighter color than this. So here let's create a function where we will create a path. So here we will use this return keyword, and we have this path class from this compose UI graphic, and we will use this apply function So we get the access of this class here in this apply block. So here we have many functions. First let's use this line2 function. And this line2 functions needs the offsets. We need to provide the x coordinate and the y. Let's take something like 100f and 100f. And this path we can draw in our canvas. Here we have this draw path function and this needs the path. So let's provide our path from this create path function. And this also needs some color and let's select some black color. Here the line is not drawing, so we also need to specify the style. By default it has the fill style, but we will use the stroke. And we need to provide the width and let's take 10f. And now we can see there is a line on our canvas. And if we make this x coordinate 500 and this y coordinates 800, and we can see there is a big line. Here with this line2 function we are defining the endpoint of this line, and by default if we don't specify the starting point, then this canvas will take the top left 00 as the starting point. So to define the starting point we have a move to function. Let's select this move to function and this time let's provide this 100f and 100f x and y coordinates. And now the line is starting from that 100f and 100f coordinates. And suppose if we need to draw a triangle, so how we can do so? After this line2 function, let's also define another point with this line2 function. This time let's take again this x offset as the 1000 and this y as the 100. And we can see both these lines are ending at the same y coordinates because we have specified the 100f and 100f. Now next we want one more line that connect this line to that point from where we started. So again after this we can use this line2 function and define this 100f and 100f. And here is our triangle. And if we want to optimize this, here instead of this line2 function, we can simply call this close function. So this will join this point with the starting point from where this path started. Now next let's define a triangle with another path. So again let's copy this path and after this let's paste it and change the name with create rectangle path. And delete these points and let's start this path from something like 500 and this one 1500. And let's take this path, use another draw path function in our canvas, and this time we will use our create rectangle path function. And here we have defined this starting point. Next let's use this line2. This x offsets we can use same 500, but y let's use this 2000. And here we have a line, and after this we need one more line. Here we need to keep this y offset same, and again make a copy of this line2 function, and this time we need the x offset same, but this y offset again let's go back to 1500. And here we have another line. Now here after this we have two options. Either we can use line2 function to go back to the starting point, or we can simply use this close function to close this path. So this is how we create these paths. And if we need this rectangle as the field, so here Instead of this stroke, we can simply use this style as the fill. So here we have a filled rectangle. Next, let's define some curved paths. So first, let's copy this function and create one more function and change the name with this quadratic curve path. And here we will provide our starting point to this path, this 100, and the y, let's select something like 1000. Make a copy of this drawPath function, and this time we will use the create quad curve path function. To create a curved path, we have these two different types of curves, this quadratic curve and this cubic curve. Here the main difference is this quadratic curve have this one control point and this cubic curve has two control points. So first we will use this quadratic Bezier-2 function, and here we can see we have four parameters. This x2 and this y2 are the endpoints, and this x1 and this y1 are the control points. We need the line from 100f to the 800f on the x-axis, and y-axis we can simply use this 1000f and same value for this endpoint. These first two values are for the control points and these last two values are for the endpoint. So let's define these control points. We need the control points of this x somewhere in between of this line. Let's take this 400 and this y offset somewhere at the top. So let's select this 600. And now we can see here is a curved line. And if we move this x coordinates control point, we can change the shape of this curve. So let's take 500. And here we have a good curve. So this is how we use this quadratic Bezier-2. Here we have a single control point to define a curve. Now let's create one more function for that cubic curve. And again we can make a copy of this drawPath function and we can use this cubic curve. But this time we will start our y offset from 1300. And the endpoint also let's define 1300. And this time instead of this quadratic Bezier-2 we also have this cubic 2 function. And this cubic 2 function, here we need to define two control points, this x1 y1 x2 y2, and this x3 y3 are the end offsets. So let's make a copy of these two values and use it again. So here we have curve, and if we take this first control point x value to the starting of this 100 and this end control point to the end, and here this is how we get the curve. And let's also make this y offset somewhere closer to this baseline 700 and again 700. And here we have a good curve, and if we want a closed path, simply we can use this close function. So this will join the endpoint to the starting point with a straight line. And if we want a field, so here we can simply use a fill, and also we can select some different color, something like red. So this is how we draw the paths. Next, let's talk about shapes. In Compose Canvas, shapes like rectangles, circles and polygons are essentially predefined paths. When you draw a shapes on the canvas, you are still working with paths, just predefined ones that the system handles for you. First, let's make this little bit shorter and scroll up. And in this canvas, we are using this draw path function. So after this, let's click and type this draw. Here we can see this canvas provides a set of built-in draw functions for various shapes like rectangle, circle, oval, and line. So these functions simplify the process of drawing common shapes without needing to manually define each path points. For example, if we want to draw a circle, we can simply call this draw circle function, and we can provide these defined parameters and the compose takes care of the rest. And this center value is the center of the canvas because we are in this draw scope of this canvas. Suppose if we need something bigger circle, so here we can simply provide radius something bigger. And let's also draw a line with this drawLine function. And again this drawLine functions needs this color, and we can use a black color. And next we need to provide the start offset and these end offsets. So start offset, we can use this offset from this compose UI geometry, and X value let's use 150 and this Y value 750 and the end offsets we will simply change this Y value something like 1200, and we cannot see our lines, so let's use this stroke width 10f width. So here we have a line. In the similar way, we also have many other functions like this draw rectangle. And again this draw rectangle needs these values. So let's press tab. And here we have a rectangle on our canvas. And if you need a custom shape, you can always fall back on defining your own path and using this draw path to render it. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore, and more. Check out the course in the description and take your skills to the next level. See you there. Now that we have covered how to define and draw paths, let's take it a step further by allowing users to create paths interactively through touch gestures. Now let's see how we can achieve this. First thing, I will comment out all these draw functions. Next, let's use our drawing canvas in our screen. Make a copy of this code and we need to use in the starting, because this canvas should be on the bottom of the layer and everything else should be on top of this canvas. And next thing here, after this background modifier, we have a pointer input modifier. And here we need to provide the key. So we can provide the unit as the key because this unit will never change and we don't want this pointer input to trigger on any state change. And here in this pointer input, when we type this detect, and we can get so many different types of detect gestures functions. We have this detect tap gestures, drag gestures, and this transform gestures. So for our use case, we need this drag gestures. So whenever user will try to write something, it will drag the screen. So let's use this drag gesture, and here we will get three functions. First we have this on drag start, and next we have this on drag, and in the last we have this on drag end. First we have this on drag start. So this will be triggered when the user first touches the screen and starts dragging. And here we will get the offset from where user has started dragging. And next we have this on drag. This will be continuously triggered as the user drags their fingers across the screen, and this will provides the current movement. And here we will get the change and also the drag amount, but we are only interested in this change. And in the last we have this on drag end. This will be triggered when the user lifts their fingers off the screen, and it will signal the end of the drag gestures. Here we will not get any value. So to illustrate this, let's use some logs. And here the offset we will get with this change. First let's use this offset, and x value we will get from this change dot position x, and in the same way this y value we will get from this change, and we will use this offset to our log. And in the last we can simply log with this message drag ends. Now close this preview window and let me connect my phone. So let's copy this tag and run our app. So here is our app. First let's make this background as white. And now open our logcat and paste our tag message. So I am pressing my finger, and if I drag here we are getting the continuous value, and if I lift my finger off the screen, and then I will get this drag ends function, and we can see this is how we get the offsets. This starting offsets we are getting only first time whenever user will start dragging, and after that we will get this continuous offsets. So this on drag start will trigger one time, and this on drag will be triggered continuously, and it will provide us the offsets value continuously. Here we can see. And when we lift our finger off, then this drag end will trigger. So with the help of these offsets we can draw our own path. So let's minimize this, and let's also minimize this. Instead of these logs we will take these offsets and we will create a path. First thing, here let's create a state where we will keep the current path, and here Android Studio is suggesting the code, and we will use this code. And we will also keep a state of all the paths user has drawn. So again let's duplicate this, and this time we will keep all the paths, and rename this to current path, and scroll down, and here on this on drag start we will use our current path, and here we will use this move to function, and here we will provide the offset from where user has point the finger, and in this on drag we will add lines in this path. So here what we will do, we will use this line to function, and we will add the new offsets to this line to function, And in this on track, we will simply take this current path and add into our list of paths. And here we need to update our state. We need to provide this type of list as the path. And initially this will be a empty list. And after this, let's make our current path and initialize it with the blank path. And in our draw scope, here we can call this draw path function, and this needs the path. First we will use the current path, and we also need to provide the color, so let's simply use the black color. And we need the style as the width, and we also need to use draw path function for all our existing lines. And here we can use this suggested code. We will take all the paths and we will draw each paths. So again, let's run our app. So let's drag, and here we are able to draw some paths, but here we are not able to see the path we are drawing currently. So what we will do, I will update this code a little bit. Here let's use this current path is equal to path dot apply, and we can use our move to function here. And let's run it again. Still it is not showing the path. So let's change this code little bit more. Let's use one more state where we will keep the starting offset, and initially we can keep the offset 0. And here on this on drag, we will not update our path, rather we will simply update our starting offsets. And these starting offsets we can use to create a path here. Next, let's make this current path as a nullable. And initially we will keep the null value. And here we will calculate first the existing path. And we will take this current path. If this is null, it means we are assigning the value first time. So we will use this path dot apply, and we will use this move to function. And here when we will update this current path, first we will add the existing path, and then we will call our line to function. And in this on drag end, we are getting this error for nullable, and here we will save the new path with the current path. If this is null, then we will save the blank path. And after adding the current path into the paths list, we will make this current path as the null. And let's scroll down, and here it is giving error because of that nullable. So let's wrap this with let block and run our app. So here is our app. Now let's draw something, and we can see the drawn path at the real time. That's wrap up today's video. We have covered the essentials of working with the Compose canvas, paths, shapes, and how to capture user inputs for drawing. In the next video, we will take it a step further by creating paths for different shapes and using a view model to manage and store these paths efficiently. So make sure to like, comment, and subscribe if you are excited to see more. And remember, if this video hits 50 likes or 50 comments, I will release the next part of this series. Thanks for watching, and I will see you in the next one.